Hello children, welcome back to chemistry class. Today we are going to discuss very important topic of chapter state of matter. Previously we have discussed some portion of this chapter and today we are going to discuss hydrogen bond. What is the role of hydrogen bond? How does it affect the structure of molecules? Let us see, that will be discussed here. And when in hydrogen bond form, and is the hydrogen bond is a type of a intermolecular force. So these things will be clear here after discussing this topic. Okay, let us see here hydrogen bond. So if we see here about hydrogen bond, we will observe that hydrogen bond is one type of dipole interaction. Means hydrogen bond is one type of dipole interaction. How it can be said like that? You might be knowing when hydrogen bond is formed. Hydrogen bond is always formed when two polar molecules are there. It means when hydrogen is bonded to more electronegative atoms. When hydrogen is bonded to more electronegative atom, so charge developed, partial charge developed in the molecules, means hydrogen is carrying positive charge, partial positive charge, and electronegative atom is carrying partial negative charge, and the positive negative charge portion of one molecule attracts the partial positively charge of other molecules, and this is known as hydrogen bonding. Means it is one type of attractive force, but it has been observed some variations also here. And how does it affect the property? So let us see here, students, dipole interaction. It is one type of hydrogen bond is also dipole interaction. Means dipole means a hydrogen bond is always formed in a molecule which is bonded to more electronegative atom, is have permanent dipole moment, then hydrogen bond is being formed. It means when hydrogen, just look, see here, when hydrogen, just you see, if hydrogen is bonded to more electronegative atom, means there will be negative charge and here positive charge. So dipole is already present here, and when it react with other molecules like that electronegative atom, means we can take here two molecules we can take of this. So here hydrogen and F, just sort of see here. So what is happening here? Negative charge there and positive charge here. So what is happening here? It is being attracted and one bond is being formed. This is hydrogen bond. HB means hydrogen bond. So what we observe here? We observe that when hydrogen is bonded more electronegative atom, and if a hydrogen is bonded to more electronegative atom, there will be permanent dipole in a molecule. And when two polar molecules come closer in which hydrogen is bonded to more electronegative atom, form hydrogen bonding. So this is also concept that if hydrogen is bonded to more electronegative atom, it may form hydrogen bond with other molecules who is already bonded to more electronegative atoms. It may be within the same type of molecules, but it may be in different type of molecules. So let us see how does it is here. So my point is that dipole interaction. It is one type of dipole interaction. It is dipole interaction, and when dipole is produced, when hydrogen is bonded to more electronegative atom like oxygen, nitrogen, and fluorine. Okay, or any other more electronegative atom, maybe chlorine also, maybe Cl also. Here HCl we can take here, HCl also we can take here. So it is observed that if it is bonded to more electronegative atom, it means polarity is produced in molecules, and polarity is produced in a molecule means the polar portion of one molecule attract the polar portion of other molecule, means oppositely charged, means positive portion of one molecule attract the negative portion of other molecules, and a bond is formed between them, that is called hydrogen bond. So you might have heard that phone, about phone you have heard here about phone here, but phone means most electronegative atom, if hydrogen is bonded to most electronegative atom. So let us see here that hydrogen bond is bonded to highly electronegative element. Means if when hydrogen is bonded to highly electronegative atoms, it can form hydrogen bond with same type of molecule or different type of molecules in which hydrogen is bonded to more electronegative atom. Yeah, the energy released during this, is 10 to 100 kilojoule per mole. Energy release in this is 10 to 100 kilojoule per mole. It means this energy is enough. Means this energy, how much energy is being released, means 10 to 100 kilojoule per mole. This energy is enough to determine the properties and structure of many compounds. Means this energy, what energy is being released during formation of hydrogen bond is that 10 to 100 kilojoule per mole, and this energy is enough to determine the structure and property of molecules. And if we talk here, some examples I have taken here, like protein structure is decided, structure of protein is due to hydrogen bonding, and nucleic acid due to hydrogen bonding. They have fixed structure, means due to hydrogen bonding. Means in simple word, if we see here, in protein hydrogen bonding present, and in nucleic acid hydrogen bonding is present. On that basis we can say this is okay. So what we got idea here, we got some idea. Hydrogen bonding also dipole interaction, because hydrogen bonding is always formed in two polar molecules in which hydrogen is bonded to more electronegative atom. So on that basis we can say it is one type of dipole interaction. But some more points we have to see here. What are the points? Let us see here. Here we talk here that intermolecular forces are attractive forces. When two molecules come closer, they put repulsive force also. Means when two molecules are brought closer, similar charge repel to each other, and opposite charges attract to each other. Like this, if we are taking two molecules in that, so if we are bringing two molecules in that, nucleus of one atom will repel nucleus of other molecule. Nucleus of one molecule will repel the nucleus of other molecule, and electron of one molecule will repel the electron of other molecules. It means oppositely charged here. Opposite charges, we can write opposite charges. Opposite charges attract each other. Okay. While similar charges repel each other. Okay, so you see here, if we have taken two molecules, so nucleus of this will repel to each other, electron of one molecule will repel to each other, but oppositely charged. Opposite means oppositely charges will attract. Means this positive charge of this will attract electron of molecules, and just you see a nucleus of second molecule will attract electron of this. Just sort of see here. So what we observe here, oppositely charged attract when molecules are brought closer. So the similar charges repel each other and opposite charges attract each other. And other point we see here, in the other cases, and this repulsion becomes more when they comes closer. Because of this, liquid and solid are not easily compressible. Just love see here, when we are bringing the molecules and when they came closer, these repulsive forces are stronger. This repulsive force is stronger, and because of that, solid solid and liquid. Solid and liquid are not easily compressible. And repulsive forces, what is repulsive forces? Repulsive forces is directly proportional to distance between the molecule. Means we can write R. Repulsive forces are directly proportional to distance between two molecules. So as the distance between two molecules decreases, this repulsive force increases, and because of this repulsive force, it is not easy to compress liquid and solid. But in gases, it can be easily compressed. Here. So this point you have to remember here. What is that? Means as the distance between two molecules decreases, repulsive force increases. Sorry students, here we can write here distance is one reversely. Sorry, here we can reverse here. The distance is increasing here, then a force will decrease. Okay, let us see here. So students, let us see here. Means force, what I told here, by mistake it happens. Repulsive force is inversely proportional to distance between the molecules. As the distance between them decreases, repulsive force increases, and because of repulsive force, we can't compress solid and liquid. So due to repulsive force between the molecules of solid and liquid, we can't compress them very easily. So what idea we got here? We got here some point in one line. I would like to summarize here. Here we got that hydrogen bonding is just dipole-dipole interaction, and it occurs in polar molecules. In polar molecules, when hydrogen is bonded to more electronegative elements or more electronegative atom, and the positive portion of one molecule is being attracted by a negative portion of other molecule, and the hydrogen bond is formed between hydrogen and next molecules more electronegative element, and that is called hydrogen bonding. This hydrogen bonding we talk here. This hydrogen bonding here, and all the internuclear forces are attractive forces. But when molecules are brought together, when molecules are brought closer, so with the attraction force there is a repulsion force also. When they come closer, so similar charges repel each other, and opposite charges attract each other. In the case of solid and liquid, it has been observed the repulsive force is maximum. In case of solid, repulsive force is maximum, so that can't compress. But in liquid, little less, so it can be little compressed, means slightly can be compressed. And compression is directly proportional. Means we can say here, just all of us here, means a repulsion is inversely proportional to compression. Inversely proportional to compression means if force is more, it can't be compressed. Okay, so let us remember here. And next topic is this thermal energy. Let us see how this thermal energy is related with kinetic energy and movement of particles. And what is thermal motion? So thermal energy is the movement of or motion of atoms or molecules. Thermal energy is the measurement of motion of atoms and molecules in a given substance. Means thermal energy is a measurement of motion of particles, we can say. Particles means atom and molecules may be here. And thermal energy here. Thermal energy is directly proportional to temperature. As temperature is being increased, thermal energy of particles means atoms and molecules increase. Here, other points is here. Thermal energy is the measurement of kinetic energy. Means motion of particles. Motion of particles means kinetic energy. Motion of particles means kinetic energy. So thermal energy is measure of kinetic energy. Means if thermal energy is high, kinetic energy of the particles of matter will be high. Okay. Other points will be say movement of particles. Movement of particles directly proportional to kinetic energy or thermal energy. Means kinetic energy and thermal, and this is also known as thermal motion. Let us see one more time, students. Here thermal energy. Thermal energy is related to motion of particles. In particles we can say atoms and molecules, and thermal energy is directly proportional to temperature. Thermal energy is directly proportional to temperature. If temperature of matter is high, thermal energy will be high, and thermal energy is also related with the measurement of motion. And if particle is moving, we say that has kinetic energy. So in other sense we can say here the thermal energy is the measurement of kinetic energy of particles. Other points is the movement of particles is directly proportional to kinetic energy or thermal energy. Means thermal energy and kinetic energy proportionally related. So we can use thermal energy or kinetic energy, any one we can use here. And other point is thermal motion, and these particles are moving due to thermal energy. So this type of motion is known as thermal motion. Okay, this type of movement is also known as thermal motion. So it might be clear, thermal energy means measurement of motion of particles, atoms, maybe molecules also here, and thermal energy is directly proportional to temperature. Okay, and thermal energy and means if particles are moving, so they might have kinetic energy. So overall we can say it is average measurement of kinetic energy, and movement of particles directly related to thermal energy. And these particles are moving due to heat. Because of that, this motion is known as thermal motion. Let us see here what is the relation between intermolecular forces and thermal interaction. Intermolecular forces and thermal interaction. Here let us see here. So intermolecular force try to keep the molecules together. Intermolecular force try to keep the molecule together, while thermal energy tends to keep apart. Means thermal energy and intermolecular forces are two opposite terms. Thermal energy thermal interaction try to keep the molecules away from each other, but here intermolecular forces try to keep molecules together. Here, so how does different states are existing? So different states of matter are existing due to balancing of intermolecular force and thermal energy or thermal enthalpy. Here thermal energy or thermal enthalpy. So due to balancing of that, here thermal intermolecular force and thermal interaction. So what you got here? Just you listen here. What? Intermolecular forces try to keep the particles together. While thermal tends to keep apart. Means they separate out. How do the different states existing? When different states are existing due to balancing of thermal energy and intermolecular force. State of matter are results of balancing between the thermal and intermolecular interaction. One more point, if intermolecular forces are very weak. But molecules do not cling each other. Till that time, energy or thermal energy of particles are not lowered by lowering the temperature of the substance. Just one more time. Weak if van der Waals force or intermolecular force is very weak. Here intermolecular force is very weak. So molecules do not cling. Till that time, thermal energy of particles is not decreased by lowering the temperature. Okay, so this be seen here. When thermal energy of particles are being lowered by lowering the temperature, the molecules can be liquefied. Can be liquefied means if we want to liquefy the gas, we have to lower the temperature of gas. And by that we can liquefy the gas here. So till that time the gaseous molecules will not be liquefied. Energy or thermal energy of particles is not being lowered by lowering the temperature of the system. So let us see here the interaction means intermolecular forces versus thermal interaction means thermal interaction and intermolecular forces are two opposite terms. Intermolecular forces try to keep the particles together, while thermal enthalpy or thermal interaction tends to keep apart from that. So how does different states are existing due to balancing of intermolecular forces and thermal interaction. If intermolecular forces are very weak, and cannot be lowered. Okay, means if intermolecular forces are very weak. Okay, but they the particles or molecules do not cling to each other. Till that time thermal energy of the particles is lowered. So how we can lower the thermal energy of particles? By decreasing the temperature of system we can lower the thermal energy. So if we are intermolecular forces here, intermolecular force is weak here, it is weak and we cannot liquefy it. Till the time a thermal energy is reduced thermal energy. Even we want to liquefy it, so we have to reduce the thermal enthalpy of this. So let us see the order of this and how does it exists in different state of matter. So I am talking here, just sort of see here if intermolecular forces like this order is there: intermolecular, solid, liquid and gas. This is the decreasing order of this is the increasing order of intermolecular force. Okay, and if we arrange the thermal enthalpy, so if we are arranging solid, liquid and gas, so thermal enthalpy increasing in this order. Okay, so this is increasing order of thermal, increasing order of thermal enthalpy or interaction. Okay, so this we have discussed here. What we have discussed here: intermolecular forces versus thermal enthalpy. Means for existing state there should be a balance between thermal enthalpy and intermolecular force. Even intermolecular force is very weak, but it can't the liquids can't be Just here once more, here intermolecules are very big at force, but it can't be liquefied till the particles thermal energy is not reduced. And how we can reduce the thermal enthalpy of particle? By reducing the temperature of that. When van der Waals force means intermolecular force is very big, and we are reducing the thermal enthalpy of particles of substance, then it can be liquefied here. And other points here, it is weak and it can be reduced only by reducing the thermal enthalpy of particles. And if we talk here, what will be the order of thermal enthalpy and here intermolecular force. So this is the order, increasing order of intermolecular forces, and this is the increasing order of thermal enthalpy. Okay, this is the increasing order of